The formula property is among Notion's most powerful yet underutilized features. So let's explore the fundamentals of formulas and then build 3 practical examples that are universally applicable for business workspaces. And for your reference as you practice, you can access those examples as a template on Notion Market, which you'll find linked within the video description. So what is Notion's formula property? Unlike text, number, and date properties, the values of formula properties are generated automatically. You compose a formula once and then it executes for each item in the database. And typically that formula is going to reference other properties within the database. So because the values of those referenced properties will be different for each item in the database, the output of the formula can also be different for each item in the database. So this age property is a formula that references the birthday property, which is a date property. And because each of the birthdays are different, the output of the formula is also different for each person. So why use the formula property? The utility of formulas is really endless, but you can think about their purpose in 2 categories. The first is to merge and reformat properties. So as you'll see, in a database that has a first name and a last name property, both text properties that are manually input, we can use a formula to create a full name property by combining the first name and last name. You can also use formulas to reformat dates well beyond the limited date formatting that's native to Notion. So then the other primary use of formulas is to calculate new values from other properties. That's what we did when we calculated the age of each person in this database using each person's birthday. Another common example is a products database where we have a variety of different pricing variables, and we can use formulas to automate many of those pricing variables because they reference one another. So let's look at the anatomy of a formula. To compose a formula, you'll create a new formula property. We'll just call this one formula for demonstration purposes and choose the formula type. And then you can click within any cell within that property to open up the composition window. And remember, you just compose the formula once, and there's going to be an iteration of that formula for each item in the database. So when you compose a formula, you're going to be working with 3 kind of types of elements. And the first is values. These are the inputs, what you're calculating or reformatting. And values are really the only required element for a formula. Technically, a formula can just consist of a single value. Now, values can be literal values that you just input directly into the formula, and they will be unchanged for each iteration of the formula. Or as we saw, they can be references to other properties. So for each iteration, it's going to pull in the value of the property of the current item. So it can be different for each item in the database. And values are going to be specific data types. So we'll have numbers and dates and text strings and booleans, which are true and false. So let's take a quick look at a literal value and a property reference to see how that works. Now, a literal value could just be the number 2. We are not referencing another property in the database. We're simply typing the number 2, and it is going to be the same for every iteration of the formula. So we can click done, or on a Mac, we can hit Command Enter. And so you can see here that the output of the formula is the same for every iteration because it didn't reference another property. It used the literal value of 2, which of course is a number. Now, if we wanted to reference the age property, the way that you do that is you start with the prop keyword, and then in parentheses, you put the name of the property in quotation marks. In this case, we would type age and then hit Command return, and we can see that the formula simply reflects the value of the age property, but it's different for each item in the database because the age property, which is referenced by the formula, is different for each item as well. So these are inputs. And then the second kind of overarching type of element you'll use in formulas is operators, and these are kind of the actions that you perform on the input values, and they're placed between the input values. So one type of operator is arithmetic operator. That's your plus and your minus and a slash to divide, a star to multiply, and then we have the percent sign called the modulus operator, which returns the remainder after division. So if we come back to our sample formula property, if we want to use 2 again as our input, we can simply add 2 and 2. The plus sign is an addition operator in this instance. Command return, and we get the sum of 2 and 2 in every instance because we used literal values, which of course is 4. We also have comparison operators where we can compare input values. You're familiar with greater than, less than, greater than or equal to, less than or equal to compare whether two values are equal. We have 2 equal signs. To ask whether they're unequal, we can use the exclamation point and an equal sign. So these tests are going to return a Boolean value of true or false, and in Notion, that's going to be represented by a checked or unchecked checkbox. So sticking to our literal values of 2 and 2 to test whether they're equal, we can use a double equal sign, and we can see that we get a checkbox for each item. If we want to test whether they're unequal, we can use that exclamation point and equal sign, and our boxes are now unchecked. So depending on the value types of your inputs, operators can take on different meanings. So we saw that the plus sign is an addition operator when it has a number on either side of it. But if you use a text string on either side of it, it becomes a concatenation operator. It merges those text strings. So coming back up to our sample formula, the text string is input using quotation marks. So if we use LeBron and then a plus sign and a space and another plus sign and a James, then these plus signs are going to be concatenation operators that are going to merge these strings into a single string. So we get LeBron James returned in every iteration of the formula. If you are to use a plus sign with a string and then a number, you'll get what's called a type mismatch. And this is one example of why it's incredibly important to remain mindful of the data types that you're working with when you're working with formulas, because in many cases you'll encounter type mismatches. So going back to our data types, we have numbers, dates, strings, and booleans, and you can learn more about these value types in another post I have called Meet Notion's Formula Property. I'll link to that within the video description as well, because inevitably you'll encounter these type mismatches and you'll want to know exactly why it's causing that issue. So let me just cover one other concept in these data types. You can see here that these numbers are aligned to the right. The age formula returns a value of the number type. Numbers are always going to be aligned to the right. But if we quickly insert a text property here, we'll just call it text, and if we type 27, 33, and 35, you can see that these values are aligned to the left. So operators, and as we'll see, functions that need a number as its input are going to need the number type. If we try to use a text string, which is what these values are, then it's going to throw an error. So always remain mindful of the data types that you're working with. So I mentioned functions, and those are kind of the third type of element that you'll be working with when you're composing formulas. And they're kind of packaged actions to perform on your input values. And the way that you use a function is by writing a keyword, and then within parentheses that follow the keyword, you insert the values. And in the case of functions, they are known as the function's arguments. So on the Notion formula cheat sheet that I have at notion.vip/formulas, you'll see a comprehensive list of functions. And for each, you'll get an explanation of what they do and what arguments they accept. So let's take a quick look at what a function looks like. If we come back up to our sample formula, we used the plus sign to add 2 and 2. It was the addition operator because it was surrounded by 2 numbers. But for each operator, there's also kind of a corresponding function. So the add function is going to return the sum of its arguments. So if we type the keyword add and then open the parentheses, it takes 2 arguments, the 2 numbers we want to add together. So we'll insert 2 and another 2 separated by a comma. Those are the 2 arguments, and then we close the parentheses, and we can see here that we get the sum of 2 and 2 in each iteration of the formula. Now, typically you're going to be referencing other properties as your inputs, as I mentioned. You won't be inserting them literally that often. So we can change one of these values to a reference to the age property, because that age property is of the number type, so it works with the add function. So remember, to reference a property, we use the prop keyword, and then within it, we type the name of the property we want to reference. So we can see now that each of the return values are different for each iteration of the formula because we're adding 2 to the age, and each age is different. So again, you can learn about operators and functions. You can reference comprehensive lists of both with explanations at notion.vip/formulas. That's where I have kind of my Notion formula cheat sheet. So let's move on to our examples of these fundamentals of formulas. In a lot of instances, it can be helpful to count the number of days since a certain date or the number of days until a certain date. So if you think about maybe having regular check-ins with clients, and you have a database of clients and a property, a date property that says when the last check-in was, you can use a formula to calculate the amount of time since the last check-in. And if that amount of time reaches a certain threshold, you can use database views to kind of surface those check-ins that have become stale, that need attention, and act on them accordingly. And then we can also use formulas to count down to an upcoming date or deadline. So if you think about a task deadline, for example, it can be helpful to count down the number of days until the task is due. It makes it really easy to see how much time you have to complete the task. And once again, you can use database views to surface any tasks that reach a certain threshold, such as those due maybe within the next 7 days, or even those that are overdue. So let's take a look at exactly how to do that. I'm going to wipe out the existing formula here so that we can recreate it. So we have our formula property. We've called it days remaining. So what we want to do is we want to find the amount of time between the current time and the deadline for each task. So for that, we have a particular function. It's called the date between function. And when their keywords kind of contain multiple words, they're going to be written in camel case. They're all one word, but the first word is going to be all lowercase, and each subsequent word is going to be capitalized. The first letter of it is. So the date between function accepts 3 arguments. It accepts the end date, and then it accepts the beginning date, and then it accepts the units that you want to return the value in. So let's take a look. We have our date between, which we'll type in camel case and then open the parentheses. Now we want first to include the end date from our date range. So we are going to reference the deadline property in this database. So remember, that's the prop keyword and then the name of the property within parentheses and quotation marks. So then we type a comma and move on to our second argument of the date between function, which is going to be the current time. Now in Notion, you have the ability to kind of dynamically insert the current time, which will always remain up to date, using the now function with no arguments. So anytime we look at this database, it's going to calculate the amount of time between the deadline and now, and it'll always remain current. And then the third argument is the units that we want to return this amount of time in. And you type it using all lowercase and plural in quotation marks. That makes it a text string. So in this case, we want to return days, the number of days between these 2 times. And then we close out the date between. So we have our 3 arguments. We have the end time, which is a reference to the deadline property, the beginning time, which is going to remain now at all times, and then the units as the third argument. So when we do our command and return, we see that we have the days remaining until each task is due. And then we could go and configure the views, sorting and filtering accordingly. So that is calculating days until a deadline. Let's move on to price calculations. Now, this isn't actually a database that you would have in your workspace. It doesn't make a whole lot of sense to have all of these properties together. Some of them would be related to orders rather than products, and a couple of other databases, particularly if you're an e-commerce operation. But for the sake of demonstration, I've included a variety of different sort of pricing variables here. So what I'm going to do is, once again, wipe out the existing values of the formulas so that we can populate them together. So we're left with 2 number properties here. These are the only 2 properties that are going to be populated manually, and they're going to be different for each item. And that's going to be the cost to produce each item and then the quantity we want to include. So like I said, some of these properties would likely correlate more with an order than just a products database, but for the sake of demonstration, we're going to include it here. So when we have the cost, we might want to mark up that cost in order to determine the selling price. So what we're going to do is, let's use the markup percentage first. And instead of using a number property here, even though the markup percentage is going to be the same across all items, we can just enter it once, just a literal value, and it will populate for all items in the database. So rather than having to enter a markup percentage for each item manually, redundantly, we can just do it once. So let's say that we want our markup percentage to be 20% for all items. If we just enter that literal value here, it's going to give us 20% for every item. So then the markup is going to be the cost times the markup percentage. So that's going to be 2 property references separated by the multiplication operator, which is that star. So we will reference cost. We'll use that star between them, or the ampersand, and then markup percentage. So now we have the markup for each item. So then what we can do is let's add a price property here. This is going to be the price that we sell it for. So let's make that price property a formula. And the price is going to be the cost plus the markup. So we can once again just use that addition operator. With two property references. Determine the price, and we want that formatted as $1. So then we have that manually entered quantity. For shipping, let's just call it a flat rate for all items, which is 10. We can input that literally, and it will populate for all items. So our subtotal then can be the price times the quantity. So we'll move that over because it's kind of in advance of shipping in this sequence. So if we want the price times the quantity, we'll use two property references separated by that ampersand for multiplication. So we'll start with price times quantity. And that is going to give us our subtotal. And then we've already populated shipping. Now let's say that tax is going to be consistent across all items. So we'll use a formula with a literal value for that. Let's call it 5%. Or, you know what? Let's call the tax rate 5%. And format it as a percentage. And then that tax is going to be a formula that multiplies the price times the tax rate, or it multiplies the price plus the shipping, the subtotal plus the shipping times the tax rate. So, subtotal as a reference, plus shipping as a reference. And then we're going to want to multiply that by the tax rate. But because of the order of operations, we're going to wrap this first part in parentheses, and then we can multiply it by the tax rate. So another property reference. And that is going to give us the tax for each item, which we will format as $1. And then for the final price, the total price, we want the subtotal plus the shipping plus the tax. So we will just use addition operators for that. First, a reference to subtotal plus a reference to shipping plus a reference to tax. And that's going to give us the total for each product. Now, again, this is not an entirely practical example because this intermixes some properties that would apply more to orders rather than products themselves, but you can get a strong sense of how we're using formulas for these various sorts of calculations that reference one another. So let's move on to our last example, and that is merging first and last names. Now, I like to, in my people databases, like to keep first names and last names separate because I like to sort by last names, and then I like to use first names within mail merge tools to personalize emails and other messaging. So I'll typically write first names and last names, and you can have the full name then populate automatically. So this is our people database, a link to it that we were working with previously. That's why we see this dummy formula property here. So I'll go ahead and delete that to keep us nice and tidy here. So currently Notion does not offer the ability to populate a title property using a formula like Airtable does. And that is a feature in high demand, particularly from me. So hopefully we'll see that soon. But in the interim, what I do for many of my databases, if I want to generate the title property automatically, what I'll do is I'll create another property called title generator. And that'll be the formula that I want to use. And when you have your title generated using this formula, it's really easy to just copy and paste real quickly within the title property, so that then you can have a nice unique value for each title, and it can be unlike any other database and easily searchable. So in this case, we have text properties for first name and last name. They're manually entered, and what we want to do is combine them with a space between them to generate the full name. So we could just use the concatenation operator, that plus sign, like we saw previously, but for the sake of learning, let's use another method, and that is the join function. So the join function is going to join two text strings, and it's going to specify a delimiter to place between them. So the first argument of the join function is going to be that delimiter. It needs to be provided as a text string, so that means that it is wrapped in quotation marks. And then the second two arguments of join are going to be the two text strings that you want to join together on either side of that delimiter. So we'll type that join keyword, open our quotation mark, and the first argument is going to be the delimiter, which in our case is just a space. And then the second two arguments are going to be the first and last names, references to those properties. So the first is first name, and the second is last name. So those are our three arguments for the join property. We can close it out with a quotation mark or with a parenthesis, and then we have our full names nicely generated here. So in theory, as you're adding people, if you add them in bulk, you can copy all the generated names in bulk. If you're adding them one at a time, you can just copy and paste them one at a time, but just highlight whichever ones you want to copy and paste, hit that Command C, and then come over to the actual title property and paste it in there. And that's generally much quicker than manually typing the full names. So in part 2 of this kind of formulas for work series, we'll see how to split first names and last names from the manually entered full name, which is a little bit more efficient. You'll be able to just enter that full name, and then it'll split the first name and last name around that space. That's a little bit more complex than this sort of 101 version. So in the interim, you can just use that title generator or just practice with it if you like, and then we'll explore that new approach next time. And if you encounter issues with that or any other issues that you experience as you practice these formula fundamentals, just let me know on Twitter, and I'll be happy to walk you through them. And again, you'll have that template available on Notion Market that I will link to from the video description. So thanks for tuning in, and I'll see you on the web.